Hello, my name is Anish Kothapalli.
I am Andrew Pan.
I am Tejas Maire.
And I'm Rahul Baragur.
We are four students from Farmington High School looking to revolutionize the future of sports medicine.
High school athletes account for 2 million injuries and 30,000 hospitalizations every year, the vast majority concerning contact sports such as football. By the time a player has to get carted off the field, it's often too late to save their season or even athletic career. While a sudden major sports injury is easily diagnosable in a hospital trip featuring an experienced doctor and x-ray, minor injuries are the complete opposite.
The most recent and prominent example of this is none other than Drew Brees, the quarterback for the New Orleans Saints. Brees endured multiple hits in the chest throughout the game, but regardless, he continued to play, exposing himself to additional dangers.
The initial hits may not have been too serious, but as the impacts accumulate, the damage became increasingly concerning. And that's exactly what happened with Brees. After the game, an x-ray showed that Brees suffered 11 rib fractures, something that could have been prevented if he sat out of the game. This concern is amplified when looking at the high school setting where teenagers and young adults are often poor at self-diagnosis.
We're looking to combat this exact issue with our innovative diagnostic process, ScanPact. ScanPact consists of both a physical bodysuit with integrated force detection spheres and a sensor system combined with a user-friendly app. This one-piece compression suit would be worn by the athlete under their padding as tightly to their body as possible to provide for the most accurate results. Spheres are woven along the entire surface. The cost of the suit is $80 and the app comes with a seasonal subscription.
Our innovation would provide a metric to track the collection of hits an athlete takes throughout a game and give immediate feedback regarding the prolonging dangers and effects on one's body. This would allow for one to get a better understanding of themselves to prevent any unnecessary long-term damage and be more cautious.
Let's start by breaking down the physics behind the sensor system and how it works. Each sphere within the bodysuit moves as the player moves, which allows the program to calculate momentum using the velocity and the mass. When a tackle is initiated, a football player would experience a sudden change in momentum, as seen in this visual. We can calculate the force applied to an area by dividing the change in momentum by the time of collision. This can then be added to the calculations of the force required to compress the balls, as determined by the elasticity constant. In addition, the location of the impact can also be recorded by determining which spheres in the bodysuit experience the greatest change in momentum. A Bluetooth receiver attached to the back of the suit compiles all of this data within the suit. We have a physical 3D printed demo representation of the material of the suit in this picture, as well as a picture of the sensor right below. This would provide for an instant communication system between the suit and the app.
In order to attend the training seminar for ScanPact, one must first have a bachelor's degree, preferably in a sports-related field such as kinesiology, exercise science, and athletic training. Our product is primarily intended for use by athletic trainers and coaches as an injury prevention measure. It can also be used as an aid to physicians and nurses. Rather than asking a player where it hurts, they can instead look at the exact location of the impact. Our product is a common ground between a self-diagnosis and an x-ray.
Moving on to the app, we've created a visual illustration of the exact interface it would consist of. We start by clicking the app on the home screen, which takes us to the app home page. Here, we have two options: to start a new scan in order to compile the real-time data occurring in that moment, or the view past scans to look at a history of damage. I'm going to start by clicking the Start Scanning button to take us to the scanning interface.
As shown, here's a live demonstration of the product in action. As I took the hit to the obliques, the sensor system relayed the hit information in real time to the exact muscle group the damage occurred to. This was then followed by hits to the thighs and then ultimately the shoulder. As you see in the video, the hits taken to the shoulders as I was sacked was more severe than the hits to the obliques and thighs, as shown by me shrugging off my shoulder and wincing. This was then indicated by the larger radius and darker opacity of the circles.
What Andrew did here is sadly a common reality for high school athletes. Andrew, though he felt the pain of the hits, got back up and prepared himself for the next play, a result of the adrenaline and the immense pressure to stay in. Andrew does not know, however, that these seemingly minor hits can lead to larger, more impactful problems later on, which is what ScanPact hopes to prevent by providing initial contact analysis to the players.
We then provide an even more comprehensive view of the injury when clicking on the specific areas as shown here. The app then creates an appropriate assessment of the location, collision force, time of impact, and a recommendation using artificial intelligence and machine learning. This can be expanded upon with any of the injured areas. This helps to provide for an in-depth personal analysis for both the player and the coach.
We also provide a button to locate past scans, as we will show you here below. When clicking this, you can see a comprehensive weekly summary over the past 7 sessions, each of which is expandable to view further details. You can also click each of the buttons placed above the graph to individually expand weeks to look at past damage and specific numbers and recommendations as well. This provides a log for the user to access at all times, which can aid them in treating prolonging injuries and end-up mortalities for changes to possible training regimens.
The impact of this innovation cannot be understated with the amount of student and professional athletes such a device could reach. This would provide the new baseline for sports injury prevention in the future by providing measurable metrics for both the athletes and coaches alike, significantly reducing the injury risks high-contact athletes face week in and week out. The specificity of the diagnosis would also allow for a much more convenient and accurate way of taking care of one's body and improving the quality of athletic performance, therefore lowering the strain on the healthcare system by preventing major injuries.
Thank you for all of your time, and we hope to share our passion among athletes everywhere.